Hi, this is Robin from Bedford Level Experiment and the podcast Growing Up 80s. And today, I thought I'd make a video. This might end up being kind of a long one. In the Commodore 64 User's Guide, Appendix L, there are all the errors that you can see on a Commodore 64, supposedly anyway. But in reality, this list isn't complete. It's missing a few items. It has a few that are actually seem to have the incorrect name. And there's actually a few that aren't basic errors. I first got interested in all these error messages. Of course, growing up with the Commodore 64, you encountered some of these error messages regularly. And some of them you would probably never see. The typical user would never see most of these error messages, I think. An experienced basic programmer might see half of them or something like that. I got interested in the error messages again recently when I was working on the video. My band, Bedford Level Experiment, wrote and recorded a song called 64738, and that's after this sys command, which resets the Commodore. And as part of the video for it, I wanted to show all the Commodore 64 error messages. I want to programmatically display all those error messages. So I wrote a little program for that. Just going to type that in here. By the way, today I'm using a real Commodore 64, as you can see, and I've got it capturing the video on a box. This is actually more trouble than just recording off of the C64 Mini or an emulator or whatever. I prefer using the C64, a real C64 whenever I can, but it can be a hassle to record. Okay, so data. I've got all these data statements. It was a little machine code program that I had written. Whoops. Little machine code program that I wrote. Okay, and then every time I do sys 49157 from now on, it'll show another error on the screen. So there's file open error, file not open error. To make it a little quicker, I can set a variable to 49157. Sysy, file not found error, and so on. Actually, I'd love to have write a little program, a little basic program that would loop through these values. But unfortunately, every time an error is created on the Commodore 64, a true error that says error at the end of the line, then your basic program stops execution. I believe there's a way to work around that, but it's a lot of trouble. Today, I'm just showing you, this is a quick example. This is how I generated all the errors used in that video for 64738. Whoop. So here we go. Okay, and we've reached the end of the errors that are built in. Any further ones, basically there's a routine in the Commodore 64 that you call with the error number from, I believe, 1 to 30. And then if you call it with a number bigger than that, then it keeps, it just generates rubbish because it doesn't actually error check that, I believe. And if you kept doing it enough times, it actually kind of crashes the machine, prints a bunch of garbage out. That's what I was doing. That's how I got the all the error messages on the Commodore 64 display. And so now I just want to work through all the errors. There's actually 32 of them, that between the ones that are visible through this routine that I'm calling, and a couple other ones that are kind of special cases, there's 32 error messages altogether. So let's go through them. Now, I'll try and make this quick. Number 1, bad subscript. In each case, I'm just going to type new, clear the screen. I'll try to do that for each and every error. I have a little example to generate each error. So here, what is a bad subscript error? Just try to set a variable such as a with an indice of 11 or greater, and you'll get a bad subscript error. That means that you're trying to set a variable in an array that hasn't been initialized yet. When you set an array, it automatically will dimension 10 positions, that is, or actually 11. Indexes 0 through 10 are there, but to go bigger than that, you have to do a dimension command. So if, for example, I did dimension A, dim A, and I dimension it to 12, okay, you can see that it thinks that A has already been defined, initialized. Okay, but if we type new, and then we do dimension A with 12 indices, then I'll be able to set A11 equals 0, and that's fine. I go up here and set to 12, that's also fine, because that's why I've defined it, but 13 will trigger the bad subscript error. Okay, moving on, number 2, the break error. Now, at first, I didn't even know that there was a break error. Like, if you write a program like this, and you run it, and you press, this is just an endless loop, doesn't do anything, press the stop button, and it says break in 10, but it doesn't say break error. And likewise, you can write a different program that just says stop, run, and that causes a break. But again, it's not a break error. So the way you can actually get a break error, and I wasn't really aware of this, or I didn't notice this, is if you try to load a disk directory, so I've got a disk here in the drive, if you load the directory and then immediately hold down stop, it'll interrupt loading the file and give you a break error. So that's the difference. Okay, moving on. Number 3, can't continue. So if you, the continue command, you just type it in like this, can't, okay, and nothing happens, no error. And if you write a program like just 10 print, like so, and hit continue, that's when you get the can't continue error. If you have a program in memory and you haven't run it yet, then you can't continue. Or another way of doing it is if you have a program that does like 10, go to 10, run, that's fine. If you stop it, you can continue it okay. But if you stop it with, again, the stop key, then, or some people call that the run stop key. Well, of course, it does say run and stop on it, but really, if you hit it by itself, it's stop. And if you hold down shift, then press it, run, it actually does a load and run. So anyway, that's a bit of trivia. So really, you can call it just the stop key, even though I know everybody calls it the run stop key. That's fine. I can deal with it, honest. Okay, what was I doing? Oh yeah, I had this program, run it, stop, you can continue that program. Okay, but if you add a second, like another line, like 5, print, and you want to clear the screen, for example, and then you try to continue, that's another way you can get the can't continue error message. So you can't modify a program and expect it to continue after. Okay, moving on. Number 4, device not present error. Okay, so that's easy. Normally, we've got a disk drive here. It's assigned to device 8, which is the typical. If you only have one disk drive, it's usually device 8. So you just simply try to load from another device, like load 9. Okay. Our fifth error, division by 0. This one's easy. Just divide any number by 0. It's pretty self-explanatory. Okay, because that's a mathematical impossibility, I suppose. Okay, extra ignored. If you have a little program like this, input, you can actually put multiple variables that you're expecting to input. Like if I run this, it wants you to type in 3 numeric values, 1, 2, 3, and that's fine. It ran okay. Try that again and put in too many answers, comma separated, extra ignored. You'll notice it doesn't actually say it's an error at the end. True, if we want to try and define what true errors are, they're those that say error at the end of the message and stop program execution. Now in this case, the program ended, but not because of the error. And I can prove that. List 20, go to 10. Okay, now let's run it. And it's expecting 3 values. That's fine. Let's give it 4 again. Extra ignored, but the program is still running. Okay, so it's just telling you that everything after the 3 values it expected, that was ignored. Moving on, the file data error. Okay, now this one's kind of a funny one. Okay, I didn't mention earlier that this first error listed here says bad data. Okay, and as far as I can tell, that actually isn't an error in the Commodore 64. However, there is an error called file data, which is missing here from this list. File not found there. It's alphabetical. File data isn't here. I'll show you how to get the file data error. I believe that's what was meant by bad data. Okay, I'm going to write a short program to show the file data error. So 10, I'm opening 1, 0. And that's opening file number 1. You can give it any number you want from, I believe, 1 to 14. Okay, and on device 0. Well, what is device 0? You're familiar with device 8. We're just talking about that. That's the disk drive. Device 1 is the cassette. You might know that. Device 0 is the keyboard. And this is one of the rare times that the C64 operating system really seems like an operating system where you can open files to different devices, including things like keyboards and the screen. So this is opening a file to the keyboard, and then from this file we want to input A, which is a numeric value. We'll run that, and here we'll give it a 5, and you see it's happy, right? Okay, so let's try running that again. Again, it's expecting keyboard input, and let's give it some letters instead. File data error in line 20. And so again, that's not listed here, and where it says bad data, string data was received from an open file, but the program is expecting numeric data. So that's why I think it's misnamed here in the C64 user's guide. Maybe that was the bad data was the error name on the PET. Okay, moving on. File not found. That's pretty easy. Just load a file with a file name that isn't on that disk, like whatever. File not found error. The next one is error number 9, file not open. So just try to print to a file that isn't open, such as file 0. We have no files open right now, so file not open. Moving on, number 10, file open. So let's open a file. Let's open number 1. It says press play on tape. It's assuming we want to open a file on the cassette because I didn't specify the device number. So we'll just hit stop and get that break error again. That's an easy way of getting it. And then we'll just try and open one again. File open error because we had already opened that file. So what you actually have to do is close it, and then you can open it again without an error. Error number 11, formula too complex. This was actually really difficult to figure out. So this is one I had to do some research on to figure out. And the main way of triggering it is to try and do nested concatenation. Here we go. Plus, sorry, this is all right. Plus 1, 2, 3, 4. There we go. Formula too complex. So it turns out when you're nesting string operations, adding strings together, of course it's not arithmetic adding, it's string concatenation. Commodore Basic can only handle 3 levels of nesting when you are appending strings together. So we've gone to 4 levels of it, and that triggers the error. Now, it can handle numeric nesting like crazy. I tried to break it. I was writing like numeric calculations that had 20 or 30, well, maybe even close to 40 levels of brackets, and it still wasn't causing any problems. Oh, I'm just noticing that my disk drive error light has been flashing all this time. Sorry about that. That's probably driving one of you crazy. Okay, so anyway, formula too complex error. And this is curious. I found in some forum an explanation. Another way of triggering this is the rarely used position command. If you go like this, 0. This is the position command, and what it does is returns the value, the current cursor position across the screen. So you see I've just run it 3 times here. The first time it was at location 0, like the very first print position, so it just reports 0. And then because of the way the C64 prints numeric values, it puts spaces around them, even for just single digits. The next one prints at 3, and then 6, and so on. It's just telling you the cursor position, what cursor position the next print will print at. But the 0 in it is actually a dummy argument. It's a function, so it needs some parameter, but it's unused. So curiously, this is sort of like a bug. You can give it a value, like an A, or even just a blank. They're just a null string, like that, and then print it. And then it'll give you formula too complex error. And this is a bug in C64 Basic where when you pass it a string as the dummy parameter, it doesn't clean up after itself. It processes that string, ignores it, but they never clean up after themselves, like garbage collection or whatever you want to call it. And so in effect, it's kind of nesting. It's doing what we did up above here. It's basically incorrectly nesting and trying to concatenate these strings, and then it tells you formula is too complex. So that's another strange way of triggering that error. Whew, too long on that one. Moving on, illegal device number. Interestingly, that's not listed here. It goes from formula too complex to illegal direct, but illegal device number, and that's specifically if you do something like load just any old file name, device 0, there. It's not allowed, and I believe like -1. Oh, that's an illegal quantity error. That's funny. So it's still expecting, it's not funny. So -1 seems that the load command is expecting a parameter in the range of 0 to something, maybe to 255. Let's see. What does it do? Load file, comma 255. Oh, it actually tries searching for that. Oh, how about that? and crashed. Load file 256 gives you an illegal quantity error. So yeah, I believe the load command is expecting a device number in the range of 0 to 255. Then there's a second check for a valid device number, and maybe the only one, let's try that again, load file, comma 0, that's when you get the illegal device number. So maybe only trying to load from device 0 triggers this error message. Maybe there's other ones. Illegal direct mode. So a way of triggering that is to try and use the input command in direct mode. Direct mode means basic commands that don't have a line number before them. So that means it's in direct mode. Do it right away. Don't wait for run. And an input command doesn't work that way. There's just no context for it. I guess it's meaningless. What would you do if you input a string? I don't know. Okay, an illegal quantity. So if you poke -1, you'll get that. Or if you try to poke dangerously 0, put -1 in location 0, that's also an illegal quantity error. The first parameter in the poke command expects a number from 0 to 65535. That's the maximum values allowed in a 16-bit parameter. And the second parameter expects an 8-bit range from 0 to 255. So a -1 breaks that, and so does a 256. That's one too many. Poke 0, 256. There you go. Okay, we're moving on to error 15. Okay, this one took me a little bit. The only way I could figure out how to do this was to involve the cassette. So let's make sure we're new. We're just going to write any little program here. How about my favorite, popularly known as 10print. Okay, and we'll run that. And this makes this neat little maze program. There's a very good book called 10print, character string 205.5 plus random 1, go to 10. That's actually the name of it, is the listing for that program. Okay, so we've written that program. Just it could be any program. Okay, I'm going to try saving that again. I probably, this tape probably has too long of a leader that can't be saved on, so I'm going to try and save again. I fast forward it slightly. Here we go. Now recording. Okay, that's done. And now I'll try verifying it. Pressing play on tape. It's a pretty good band, by the way. Okay, there, now it found it. Press the Commodore key to tell it to load. Verifying. Okay. Okay, what are we trying to do? We're trying to create the load error. So how do we do that? We will load. Press play on tape. So the only way I can figure out how to make the load error is on a tape by saving, by deliberately corrupting a program. I tried doing it on disk, like you try saving a file, and then while the disk is writing still, okay, so now I'm going to, it's found 10print, I'm going to press stop, get that break error, and now I'm going to write a new program, 10rem bork. Okay, I'm going to try to save that. Save bork. So what I've done is gone forward to the original 10print header that we verified was an OK save. But instead of loading it, I stopped the cassette recorder in that spot right after the header. Okay, now bork is saved. I'm going to rewind the tape again. And load, press play. So basically this is saving a new program right after the header, or that's what we've just done. Sorry, I'm taking so long to explain some of these things that even cassette is faster. I can load and save on cassette faster than I can explain it. Okay, now it found temprint, and we're going to try and load it. Now this is where I started writing that Bork program. And if it works, it'll get confused and break. Yay! Okay, so there it is. It found it. There's the load error, syntax error, and it's misunderstood the header for some basic code or whatever, and there's some checksums. It's found that. Okay, of course, this isn't the only way to get a load error. A lot of people experienced it because their old game was broken, like their old cassette game would break, or their data set was bad, or whatever. Okay, but I wanted to figure out a way to, in a controlled fashion, deliberately create the load error. So I've done it. Yay! Congratulations. Okay, moving on. This is taking forever. Missing file name. Okay, see here there's load and next without for. There are no errors starting with M alphabetically, but they've missed one. It's called missing file name, and the only way I know of to get it is to try and load a file from disk with no name in it. There you go, missing file name error. So it insists that disk files have an actual file name, not just a blank or missing file name. You can actually do a load from cassette 1, like from device 1, the cassette, and it's fine with that. Or you can even omit the device 1, and it will assume cassette. Error number 17, next without for. So that's easy. You can just type the word next in direct mode, and because you didn't specify a for command before, there it is. Okay, or you can do it in an actual program like this. For x equals 1 to 10, next, and then maybe you got rem blah blah blah, you got more program there, and then 30 you do another next, and if you run that, then there you go, next without for error in 30. Well, something I haven't pointed out yet is how it's pretty funny. Every error message starts with this question mark, and then it has the text, and then there's always 2 spaces afterwards, and then it says error in 30. So I'll bring that up a little bit later. It's kind of significant later. Next without for error. So this can kind of be thought of as a bug as well, where they included an extra space in the string that prints error, or somewhere anyway. Obviously they didn't need 2 spaces there. Moving on, number 18, not input file. That's easy, just to open 0. And file number 0 is, I believe, reserved by the system. Anyway, you cannot open it for input, and that's what you're doing when you tell it open 0. Not input file error. And number 19, not an output file. So here, if I open file number 1 on device 1, and then send a secondary command of 0, that means it is a read-only file. Okay, so that's opened. And now if I try to print to that file, because it's a read file, and I'm going to try and write to it with a print command, that's how you get that error. Not output file error. Out of data error. Okay, now this is a classic one here. You've probably seen this before. If you happen to hit return when you're on the ready prompt, you get an out of data error. And I think a lot of us didn't understand why that was happening when we first saw that. But what's actually happening is it's interpreting this ready, that the system itself generated, as read Y. like this, out of data, or I could just type that in again, read Y. Well, instantly, this idea of the computer itself printing the word ready at the user and then hitting return on top of it, and it gets interpreted as read Y, is kind of totally typical of text adventures back when, which is text adventures were one of the first times I think where the computer seemed kind of intelligent, especially the Infocom games where you could type instructions at it and it would parse them and do what you'd say. But sometimes there would be words in the text that the computer's giving to you, so you try to refer to them and it says, I don't know what that is. It could say, you know, you're in a dark hallway and you see firelit torches and you try to get torch. And it says, I don't know what a torch is, or whatever. And that's actually even typical today when we're talking to Siri on our iPhones or other digital assistants, and they just do not understand you, even though you think you're speaking the same language as them. Out of memory error. There's lots of ways of causing this. Here's one example. Just try to GOSUB a routine on the same line, like an endless GOSUB that never gets returned, and very quickly you'll get an out of memory error. Now, out of memory can actually mean not just out of RAM, but out of stack space, and the Commodore 64 has a fairly small stack, so it doesn't take long at all for BASIC to fill up that stack with callbacks that should be returned to, but our programming error, but our program never returns from those GOSUB calls. Overflow error. So C64 can handle fairly big numbers. You got like 2 to the 16. That's 65536. That's how many bytes there are in 64 kilobytes of memory. Or you got something like 2 to the 24. Okay, and that's 60,777,216, which is the number of bytes in my super CPU with 16 megabytes of RAM. Okay, and you can go up, bigger. When you go 2 to the 32, it's using this scientific or this exponential format to show the numbers too large. And this is when Commodore BASIC is using its floating point memory, and it can't precisely store larger numbers. It goes to this format that has, the mantissa and the exponent. And that's not an exact representation of a large number like 2 to the 32. And that's, I believe, like 4.3 gigabytes. If I'm remembering correctly, that was the limit of a hard disk partition back in earlier DOS or later DOS, early Windows days. I believe you couldn't have a hard drive bigger than 4.3 gigabytes for a while there. And that's why it's 32 bits. Or maybe 4 gigabytes of RAM would be a limit as well on some operating systems or some hardware. And back to the point, I'm trying to generate this overflow error. Error number 22. So you can do really big numbers, 2 to the 100. It turns out that the limit is somewhere around 2 to the 127. There you go. Finally, an overflow error. Basically, this is the limit of, this is the biggest number that Commodore BASIC can handle, is somewhere right between 2 to the 126 and 2 to the 127. Of course, you don't have to use, it doesn't have to be 2 to the power of anything. I'm just doing that. Us programmers like those numbers, don't we? I do. Moving on. Error 23, redimensioned array. So if you have something like dim A of 5, and then you try to do that again, you get the redimensioned array error. So it doesn't even matter that we're trying to just set to the same size we already did. And if you try to make it smaller, that doesn't work, or bigger. You just can't redimension an array. You can't, once an array is set in Commodore BASIC, there are workarounds with assembly language or pokes or whatever, but basically Commodore Basic doesn't support that directly. And the way you can run the CLR command, you've noticed I've been typing new a lot. That totally wipes out all memory. But if you do a CLR command, that just clears variable memory, and then you can do, you can redimension your array. Clear. There you go. Error 24, redo from start. If you do an input A, there's a short program, run it. It's expecting a number like 5. It's happy with that. But if you do it again and type in a string like hi, you get this redo from start error. And this is another one of those that isn't actually an error. Well, it is an error. It's informing you, but it's not one of the errors that stops execution and prints the word error as well. It actually continues and gives you a chance. Oh, why did that happen? Run. Okay, so return is probably just assuming that you want a 0 in that variable. But if you keep typing, there you go. So this redo from start is the same as that extra ignored error. Okay, a return without GOSUB. That's really easy. Just try to return, or you can write a program that says return and run it. Return without GOSUB error. So for every GOSUB, and then you have to have a return. You can't return if you haven't GOSUB'd. GOSUB, by the way, is like a goto, but it's goto subroutine, and it's a very primitive way of allowing you to reuse code in a Commodore Basic program. You can make a subroutine that can be called from multiple spots. And of course, it's an efficient way of programming in Commodore Basic, used correctly. Error 26, string too long. We can write a short program like a string equals a string plus something like whatever, x. Go to 10, and then if you run it and wait a while, there you go. The string is too long error. I believe there's a limit of 256. Error 27. And this is a syntax error. This is the one that everybody sees sometimes. So whatever, you can go 4 over twice, like Truckhead Homestar, who happens to be my son, by the way. And you get that famous syntax error with the question mark at the beginning and 2 spaces in it. And curiously, in the user's guide here, for syntax error, it actually includes the question mark and the word error, even though none of the other ones listed here have that question mark or error included. So it's pretty weird that they include it just for this one, but maybe that's a way of acknowledging the fact that people see that very often. So a syntax error is caused by typing anything into the computer that in basic direct mode that either isn't a recognized direct mode command or a program. Too many files. And this is another one that's not here. After syntax error, too many files is missing. And to generate that one, here's a little program. For x equals 1 to 11. By the way, I'm trying to make this code look pretty while I type it in, but my habits are to not put spaces in or anything because it saves space and it saves RAM and CPU time to write horrible, illegible code that's a mess. Okay, and here we go. Open X, 8, 30, opened file, 40, next. Okay, so we're just going to try and open a bunch of files. There we go. Open file 1 through 10. And when we tried to open an 11th file, that's when we got too many files. So Commodore Basic can handle up to 10 open files at once, which is actually pretty generous. I can't imagine ever writing a program in BASIC that would use more than that, but maybe they would. Error 29, a type mismatch. Commodore Basic does have a few different variable types. If you programmed in other languages that are strongly typed, like C, then you know that for any given variable, there's only certain values that can be put in. So in Commodore Basic, if you try to put a number in a string, you'll get a type mismatch error. Of course, if you go and put it in quotes, then it becomes a string literal. It's not a numeric value one. That's fine. Or if you try to take a numeric variable, string, you probably know this, but string variables have a $sign after them, and numeric values have no indicator after. If you try to go A equals something, that's also a type mismatch because the A is expecting a numeric value. How about if we do an integer variable that's specified by this % here, and try to put a float in it, like 45.5. It's fine with that, but you notice that it's rounded it off silently without generating an error. Almost done. Error number 30, undefined function. If we don't define a function but try to call it, like function X, then you get an undefined function error. Error 31. That's easy. We've got no program in memory now, so just try to run a specific line number that doesn't exist. Undefined statement error, or likewise try to go to a line that doesn't exist. Same thing. That's all the undefined statement is. And finally, verify error. Okay, so we're going to use the disk drive for this one. 10 print C64 rules and run it. That worked. Let's try saving that. We'll just give the file name test1. Okay, and that saved okay. No blinking red light, so we know it's all right. And then we will verify test1. That's comparing the program in memory, this one, with what was saved to disk. We did that earlier with the cassette. Verify works on the disk drive as well. Okay, now we will try and change one little thing in our program. And then we will, again, verify it. And it gives you a verify error because the program in memory doesn't match the program on disk. Woo! That is all 32 errors. 32 basic errors. And let's celebrate that with a little 4x. Ha ha ha. What am I doing? There you go. Yay. 32 errors. 32 basic errors. Yay. Okay, sorry about that. So, I hope you enjoyed this video. It took me a little while to put it together and maybe even longer to talk about it. If you like this sort of thing, please subscribe, please share it. Let me know what you think about this kind of video. You want to see more of this? And again, does using a real C64 make it better, or you don't care? Tell us about that. And really appreciate it. Thanks for tuning in and watching. We'll see you next time. Bye-bye.
Stop. terminate.